Welcome to the Builder, Page and Well Path tab, complete instructional video. In this video, we will cover well profiles and directional paths, well path parameters, page grid drawing range, and scaling controls. Because we know your time is valuable, and this is a bit of a long tutorial video, here is a breakdown of the contents of this video so you can skip to any specific portion you need to see. The first step to drawing any wellbore diagram is to open the Wellbore Schematic Builder, which is located under the Wellbore Genie ribbon on the far left side of the ribbon. The window will open with the Page and Well Path tab visible. This page is where we give the well a profile or a directional path, tell the program where to print the diagram on the worksheet, and adjust some scaling properties. There are four sections: the well profile section, the page grid and drawing parameters section, the well path parameters section, and the scaling control section. First, we'll start with the well profile section at the top. There are two ways we can give the well a profile. On the left side, there is the standard profile options with 5 built-in well profiles: vertical, horizontal, slant, S-curve, and double build. And on the right, we can give the well a profile by importing survey data. For the sake of this demonstration, we have preloaded casing data already entered into the program. We will cover the casing section in another tutorial. Let's draw a well with a standard profile first. For each of the standard profiles, the user will need to select a profile by checking the box next to the profile name. For this example, we will select S-curve, and the well path parameters section will display the parameters that will need to be input. Let's make this well 10,000 foot deep, with a kickoff point at 2,500 feet, a build rate of 5 degrees per 100 feet, a tangent inclination of 30 degrees, a slant length of 1,000 feet, a drop rate of 3 degrees per 100 feet, and for the final inclination, we'll bring the well back to vertical at 0 degrees. Now that we have the well parameters entered, we can click the Calc Max TVB button in the well profile section, and the program will generate a directional plan and give us the maximum true vertical depth of the well here. This is an important number to know for scaling purposes that we will cover very soon. The next step is to tell the program where to place the wellbore schematic on the worksheet, which we will do in the page grid and drawing parameters section. Microsoft Excel contains a grid system called points, where the scale is 72 points per inch, and every place on a worksheet has a points coordinate. There are 3 values that tell the program where to draw the schematic: top points offset, bottom points limit, and left points offset. If we click on the Instructions button, it brings up a window that clarifies how the point system works. The top points offset is the distance from the top of the worksheet window to the center starting point of the well. The left points offset is the distance from the left of the worksheet window to the center starting point of the well. The bottom points limit is the distance from the top of the worksheet window to the maximum TVD of the well. Going back to the builder, Wellbore Genie has made this easy. To populate these point values, we can click the Select Range button. With this tool, you can select the worksheet cells where you want the program to draw the schematic. Here we have selected range E4 through E32. The well will draw with the center of the well starting at the top left corner of cell E4, and the maximum TVD center of the well will go down to the bottom edge of row 32. After clicking OK, the points values are immediately populated in the boxes. Now where we click Draw Wellbore Diagram, it draws the well on the worksheet exactly where we selected. If you need to reposition the schematic in any direction, it can be done easily by changing the values in the page grid boxes and clicking Refresh. For example, let's say we want the wellbore to be a little bit more to the right. To do this, we can increase the left points offset value to 300. Click Refresh, and there you go. It's that easy. Now on to the scaling controls section. Starting at the top, we have the Lock TBD scaling checkbox and the corresponding box for the depth. If you want your diagram properly scaled, you will need to check this box and enter the appropriate depth. This is where the calculated max TVD value from above comes into play. For this well, we have a maximum TVD of 9,792.57 feet. value in the lock TVD scaling box must be larger than the max TVD. By scaling it, you're basically setting a maximum depth in your drawing range that everything is drawn scaled to. On the left side of the screen, I have added a vertical scale so you can see how the scaling works. The scale is at 0 feet at the top of row 4 and 10,000 feet at the bottom of row 32. You always want the value in the lock TVD scaling box to match the maximum depth that you have on your vertical scale. To draw the wellbore accurately within this scale range, we will enter 10,000 feet in the lock TVD scaling box and check the checkbox. Then we'll hit refresh, and there you have it. The wellbore scaled properly, showing the 9,792 max TV depth against the vertical scale. The TVD scaling function is most useful if you're building multiple schematics on the same worksheet or side tracks, adding a stratigraphic column, or any time that multiple wellbores or other objects need to be properly scaled with each other. We recommend to use it always. The next scaling control is the lock incremental scaling. This value is the data frequency that the well is drawn. Default is 10 feet, meaning the well is drawn with one data point every 10 feet. In most cases, 10-foot increments will give you all the detail necessary for an accurate visualization. However, if you feel that you need more data frequency, you can adjust this number all the way down to 1-foot increments. But user be warned, the lower the number is, the longer it will take your computer to build the schematic. If you have an old or slow computer, you can risk stalling your computer for long periods of time or even crashing it. If detail is not a factor in your schematic and you wish to increase your drawing speed, the increments can be increased all the way up to 200 feet. We recommend not changing this number from 10 feet unless it's necessary. The next scaling control is the lock section target azimuth factor. This only applies to wells drawn from survey data and does not apply to schematics drawn from preset well profiles. So we'll cover this in a few minutes when we go through drawing wells from survey data. Finally, at the bottom, there are two options to cast the well to left or right. This function toggles the direction of the well on your worksheet from surface, left to right. With our S-curved well, if we change it to cast well to left and click refresh, you'll see that it has been flipped to the left. Moving on now to the survey section of the well profile box. Using this method, the user can either import an actual survey from a well or manually create their own survey path to make the well profile any direction they wish. Wellbore Genie has made importing surveys extremely simple. To import a survey, click the Import Surveys button. A window pops up that contains an important message. Select a range of cells with exactly 3 columns in this order: measure depth, inclination, and azimuth. Following that instruction, we'll select the survey data to import from a separate worksheet that contains actual directional surveys from a directional company. A quick user tip: select the top row of the survey list, then hit Ctrl, Shift, down arrow on your keyboard, and it will select all the surveys to the bottom of the list. In the survey selection, there cannot be any alphabetical letters, blank spaces, or duplicate surveys, and surveys must be in ascending order, else the program will not accept them. If the program throws an error, double-check the survey data for errors, typos, letters, symbols, duplicates, or any other non-numerical or incorrect data. After clicking OK, if the survey data is error-free, you will receive a confirmation message telling you that the surveys have been loaded, and an outline for the Import Surveys button will turn green. Also, the Max MD, Max TVD, and Section Azimuth boxes will populate as well. If you wish to clear the surveys, just click the Clear Surveys button and it will clear any uploaded survey data. If you already have a survey uploaded and you wish to replace it with a new survey, simply just click Import Surveys and follow the upload process, and new surveys will replace the old surveys. Note that you cannot add surveys to existing surveys. You can only replace what is loaded. Once a survey is loaded, verify the survey box is checked. Then you can follow the same procedure as before in the Page Grid Drawing Range section to tell the program where to draw the schematic. Moving over to the scaling control section, the lock section target azimuth option does pertain to wells that are drawn by survey. Naturally, a directional path of a well is in 3D, and a well schematic is viewed in 2D. This section tells the program how to orient the wellbore schematic for viewing. By default, the program will display a well perpendicular to the orientation from the surface to the total depth, just as we see here when we click Draw Wellbore Diagram. In most cases, keeping this value the same as the section azimuth is the optimal way to view the well. However, if the user for any reason needs to rotate the well around the vertical axis to view it at a different angle, it can be done here by checking the lock section target azimuth box and changing the angle as needed. Using this well as an example, notice how this well has a back build in the vertical portion of the well. The section azimuth is calculated for TD of this well at 166.26 degrees. But this is calculated from TD. Looking at the raw survey data, notice how the azimuth data is somewhere in the 310 degree range for depths less than 7,057 feet. Let's give this a real-world scenario and assume we are in the drilling stage of this well and we want to build a schematic to show the current drilling progress. By using the same process as before, we upload the survey data this time from surface to only 7,057 feet. The section azimuth calculates to 312.7 degrees. If we draw the wellbore without locking the target azimuth, the program will use the 312.7 degrees as the target azimuth. And as you can see, it casts the back build to the right instead of to the left. The correction for this is quite simple. All surveys should come with the vertical section or target azimuth value as it is displayed here at the top of the survey sheet. Now if we enter the target azimuth of 165.5 degrees, check the lock section target azimuth box, refresh the well, it instead casts the back build to the left, correctly displaying the negative section back build. Finally, the last two features on this tab are the white background and Group All WBD Components checkboxes. The white background checkbox gives the wellbore a white background as shown here with the stratigraphic column behind it. If we uncheck the white background and refresh the schematic, now you can see the stratigraphy show through the wellbore, which gives the user the option of how they would prefer to see it. The Group All WBD Components checkmark ensures that all components like casing, shoes, cement, perforations, etc. are grouped together in one image. As demonstrated here, when I click and drag the wellbore image, the entire wellbore moves together. When we uncheck the box and refresh the diagram, each of the wellbore components are separated as their own image, as you can see here when I click and drag components away from the wellbore. In general, we recommend you leave this box checked. However, for special cases, if the user would like the images to be separated, this option does exist. This completes the Page and Well Path section. Be sure to check out more videos to learn all about the features of Wellbore Genie.